In this video we're going to get an introduction to conic sections, and when we talk about conic sections we mean a cone that is being sectioned or sliced. So in this little animation right here you can see that pretty plainly. As we slice a cone in different directions we end up with different shapes, and these shapes are mathematically important, and there's four main shapes that we're going to be exploring. The first shape comes from slicing the cone straight across the axis, and when we do that we get a circle. Now if we take that plane and tilt it and slice across at an angle, we're going to get an ellipse or an oval shape. If we were to take that plane and tilt it at the same angle as the slant of the cone, we get the familiar parabola. And finally, if we tilt the plane upward and cut through both cones, we're going to get a two-branch shape called a hyperbola. Conic sections are described by an equation that you see right here, and this equation is the same for each of the four shapes. What makes the four shapes different is the values of these coefficients A, B, C, D, E, and F. Now the coefficient B, which multiplies this x times y term here, controls the rotation of the shape, and we're not going to explore rotated conic sections. So we're going to set B equal to 0, which effectively takes this out of the picture. And so the equation that we're going to be working with is this one right here. Now the four different shapes, the four different conic sections, can be determined from looking at the coefficient A and the coefficient C. The relationship between those two determines which of these four shapes we're dealing with. So if A and C are both equal, and both of them are not equal to 0, okay? If they're both equal, we're going to have a circle. So we could have something like x squared plus y squared plus some other stuff here. Negative 2x squared minus 2y squared, and so on. If we have A and C not equal to each other, but yet they have the same sign, in other words, both positive or both negative, then we have an ellipse. This basically says if I have two numbers that are both positive or both negative, if I multiply them, I would get a number greater than 0, a positive number. So that's really what is being said down here with the same sign. For a hyperbola, same idea. We want A and C to be not equal to each other. In addition, we want them to have opposite signs. So if we multiplied A times C, we would get a negative number. And finally, for a parabola, we're going to have either A equal to 0 or C equal to 0, but not both of them. And so if you imagine what happens here then, if A is 0, then I have no x squared term and I see just y squared. And by the same token, if C is 0, I have no y squared term and all I see is the x squared term. So let's take a look at a couple of examples. In example 1 we have x squared and y squared, and we don't have any numbers in front of them, which of course means that actually A is equal to 1 and C is equal to 1. And so in this case we see that A is equal to C. Neither one of them is equal to 0, and so this is a circle. Let's skip down to maybe number 3 here. We see that we have A is equal to negative 3. Okay, A is negative 3. C is equal to 2. And clearly A is not equal to C, and they have opposite signs. Since they have opposite signs, we know that this is a hyperbola. So I'll go ahead and leave the slide up here just for a moment. You can pause the video and try to go through the rest of them and see what you come up with, and then when the video restarts I'll show you the answers. Okay, so hopefully you got this answer, this set of answers here for the conics, identifying and classifying which conic section belongs with which equation.